A single point of failure is when one of the component in your distributed system fails and it takes down the entire system with itself. And cloud was supposed to eliminate the single point of failure. I remember all those system design videos where all the experts showcased cloud as a solution to single point of failure. Well, turns out the cloud itself has become the biggest single point of failure. From shopping sites to banking apps, everything just went dark. And we realized that our so-called distributed systems are actually very centrally dependent on one of the provider's data centers. The very thing designed to make the system more resilient is now the one thing that can take them all down at once. Hey everyone, welcome back to Lazy Programmer. Today we will be talking about the AWS outage that happened on October 20th. This was just another reminder that the cloud is just someone else's computer and that computer can crash too. With US East 1 going down, suddenly every company remembered that they were supposed to have multi-region architecture. Now let's dive into the detail. This outage was a big one, affecting many popular websites and services worldwide. We'll break down what happened, how it happened, and what it means for the future. We'll also cover the impact, timeline of events, and the root cause in detail, including the technical things. But before we do that, let's just look at a quick summary first. So, nearly one third of the internet running on AWS stopped working on Monday morning. There was a glitch in AWS's internal network, specifically a DNS resolution issue in its largest region, which was US East 1. It caused hundreds of sites and applications to malfunction. AWS says the root cause was fully mitigated, but some of the requests may still be throttled. So they will be clearing up that backlog. So now let's start with the impact and scope of the issue. This AWS outage impacted completely or partially many services across the globe. In the consumer section, applications such as Snapchat, Vemo, and Robinhood were majorly impacted. In the gaming and entertainment, Fortnite, Duolingo, and multiple streaming services were impacted severely. It also impacted Amazon's own services like Amazon Service, Alexa, and Amazon Prime Video. Not only these, but many companies running on AWS for backend services experienced disruption, including Reddit, Perplexity, Canva, banking services, and even government websites. The main region which was responsible for this outage was US East 1, which is in North Virginia. This is AWS's largest, oldest, and most default region. So you can understand how much of the internet was dependent on this particular region. The dependency on the AWS is so large that when it had problems, the losses were huge. Now let's understand how the things unfolded in a proper sequence. At around 3:11 Eastern Time, AWS started experiencing outages. AWS reported increasing error rates and latencies for multiple services in the US East 1 region. By around 4:26 a.m. Eastern Time, they had identified some issues with the DynamoDB, which is a NoSQL database service. They have confirmed that endpoint for DynamoDB in US East 1 region is having significant error rates. The internal monitoring service also indicated that it's not only the external connectivity, but there is something going on in the internal systems as well. By approximately 5:01 a.m. Eastern Time, the main cause was identified as the DNS resolution failure for DynamoDB endpoint in the US East 1 region. The DNS service is like a phone book that contains detail of the service or domain name and its corresponding IP addresses. So computer can only communicate via IP addresses with each other. But to make it more human friendly, we give those IP addresses some useful and easy to remember names like google.com, because we cannot remember the IP addresses of different websites, but we can remember the names like Google, Facebook, or YouTube. So the issue was in the DNS service, which translates the service name into IP addresses within AWS's internal network. In addition to that, the issue appeared to involve a health monitoring subsystem for network load balancer as well. So at around 5:22 a.m. Eastern Time, AWS applied the initial mitigation steps. That includes bringing back the DNS resolution, ensuring the DynamoDB endpoints could be located, and beginning to clear the backlog of failed requests. Although the primary DNS issue was fixed, many dependent services were still degraded because there was a backlog of failed requests across services. AWS has applied a temporary throttling to all new EC2 instance launches and some asynchronous service calls to reduce the stress on recovering systems. Recovery across all the AWS services was confirmed by them at approximately 6 p.m. Eastern Time. Now, this is the part for technical people. What exactly broke, why it broke, and how the cascade happened. So, what exactly failed? The initial failure was related to DNS resolution for DynamoDB endpoint in the US East 1 region. Without the correct DNS, services were unable to resolve the IP address to connect to the DynamoDB. Later, AWS identified the failure was originated from a subsystem, or simply we can say a process that monitors the health of network load balancer within EC2 internal network. So when the health monitoring system failed, the load balancer falsely flagged the healthy node as unhealthy nodes, which caused the connectivity problem. So the nodes were actually healthy, but the monitoring system flagged them as unhealthy. This majorly impacted the DynamoDB. But why this single service caused a cascading failure in different services? Many services like Lambda, SQS, CloudWatch, and IAM rely on DynamoDB. These services depend on US East 1's DynamoDB specifically for metadata, coordination, authentication, and global table replication. So when API fails, these services either cannot authenticate, cannot locate the configuration, or cannot proceed with the normal operations. The US East 1 region is kind of the default region for many global services in AWS. Even other regions sometimes rely on US East 1 endpoints. The detection of issue was slower because it was an internal failure. So the external monitoring systems were slow to detect it. So in short, we can say the root cause for this issue was centralized dependency on a control plane service, which was DynamoDB endpoint that also lacked proper fallback. So what does it mean from the architecture viewpoint? So in cloud native design, we aim to avoid single point of failure. But here, despite multiple availability zones and regions, the reliance on a single region's control plane endpoint created an effective single point of failure. The DNS resolution is often overlooked in high availability designs. So when the DNS fails, everything that depends on the name versus IP checks fails. There was clearly a miss in the system while designing it for cascading failures. Recovery was another uphill task for AWS because recovery isn't just a switch that you can just turn back on. Clearing backlog takes time. So even when the root cause was fixed, system still runs degraded until the cleanup activities are completed. So now as the issue is fixed, it's time to do a retrospective analysis and understand what can be done to avoid such issues in the future. Even major cloud provider can fail in big ways. So AWS, we know it's huge. It is trusted, but this event shows that organizations must still plan for the worst. The cloud doesn't mean it is a zero risk environment. So you need to design your application for resilience, not just normal operations. We should always plan for multi-region, multi-zone architecture for our critical components. Also avoid relying on a single endpoint if possible. Another important point is graceful degradation. So graceful degradation is most underrated component in system design. But this event shows us the real impact of not implementing the graceful degradation. We can use cached responses and fallback paths to make sure our system degrade rather than fail. So often our focus is on server, storage, scaling, but DNS, health checks, metadata endpoints are completely ignored. Monitoring these internal systems is a key to identify the issues and act swiftly. This event is going to be a major case study in cloud resilience going forward. If you are building systems or teaching people how to build systems, you will want to reference this one. So that's all for this video. Drop a comment below if you have been affected by this outage or if you are working in infrastructure and have thought of how to avoid this kind of problem. So until next time, let's keep designing, but maybe keep a backup plan ready too.